What is a line source when you're talking about acoustics? Well, the most typical, easiest way of considering a sound source is a point source, which is something that is so small that it has no length, depth, or height. It's just a single point. And that means there is no up, down, left, or right side on this point. So when it emits sound, it's going to send sound in all directions at once, distributed over a sphere. I don't know if that makes sense, if you can look at, but it's going in all directions. Spherical radiation. Now, if you take several of these point sources and put them on a line, like you know those pearls that you put on your neck or something, and you lay it out, it's gonna be something like this. You got many point sources in a line, in a row. And when these ones start to emit sound, and they do it simultaneously, you can see perhaps where this is going. Get more and more and more and more of these. So it's going to create when these waves overlap, you could consider it like if there's ripples in water in a pond. All these waves will overlay on top of each other, and it will create a wave front like this that is moving. If you would do this on the water, if you would have like 20 points that was exciting the water surface, it would create a wave front like this, because it's actually the sum of all these point sources. And if you do the same thing in 3D space, it will look like a cylinder that is emitting sound. So it would be in 3D space, it would look like a line like this, which emits sound, and then you would have like the area here. It's gonna go, sound is gonna go all the way out from this one in all directions, because there's like many layers on top of each other. Let's see if I think I got some. Yeah, here's this. Now, in what way is this relevant? Where can you find these kind of line sources? Well, I'm going to show you here. This is a perfect example, because with a train, every pair of wheels could be considered. Yeah, each wheel is a point source. So here you have lots and lots of point sources in a row, and they're going to emit sound simultaneously, which will overlap with its overlay on top of each other and create this wave front that I tried to draw here. And this will be like a big line that emits sound over a cylinder. Here is another example of a line source. Every car, if you consider every car as a point source, and then when they're driving on a long line like this, the road itself, when there's heavy traffic on it, will behave as a line source. And the most important thing to remember about line sources compared to point sources is that a line source is more effective on transmitting sound over large distances compared to a point source. The point source, even though, let's say, if they have the same sound pressure level when you start out, the point source will drop off quicker, whereas a line source will propagate further. And that is important to think about when you're doing calculations of road traffic noise. If there's only one car driving, it's a point source, dies off quick. If there's 1,000 cars driving, like on this picture, it's gonna become a line source. Here's another application of line sources. You can see the loudspeakers on each side of the stage are placed close to each other. So this will create a cylindrical wave front. However, in this, it's in the Z-axis. And as you can imagine, when you're doing a live concert, it is a good thing to be able to propagate sound further without losing sound pressure level, because that means that you can lower the volume and still have proper sound pressure level at the back of the concert, and you still won't expose the ones closest to as much sound. Let's make a drawing of it. Like if you have distance here in meters, and you got sound pressure level here in dB, and then you have a point source, and you want to have a certain sound pressure level at the back of the concert, over here, a bigger distance, and the point source dies off like this, and this is the level you want to have, at least this level, so it's going to be a proper concert. But then it's going to be very loud if you're close. However, if you have a line source, you could still achieve this sound pressure level at the back, but much quieter at the front. So that's a good thing to know about line and point sources. And in today's video, I am wearing a wooden watch. And this is something that I usually put on if you're gonna have like a start of a big project, or gonna have some theme or a lecture where we're talking about acoustics in wood. I usually throw in a little detail like this, because it's a subtle thing, but there's wood here, and I'm talking about wood, and this amplifies my message. So be wary of the details. They can greatly assist you in your communication. And this is a thing. You don't have to say it. It's just there, and it's gonna do its job. So think about that. See you later.